Okay, so making some additions here to K2 and specifically to authorization. So we have a need for a token, and I've already have like your verify email token, and I think I'm using it somewhere else, but I'm finding more and more need for kind of a generic token. So let's go ahead and create a kind of generic token table, and then I'll build the API on this. So I'm in the SAS auth schema, and this is just a good example of how we create objects in K2. We use the APIs available in ArcSQL, which are fairly straightforward. And if you ever need something, you can add it. So we always have an uninstall at the top. It's commented out, so our shell script can build an uninstall script from that. And we're using the API because we're in SAS auth. If we were in ArcSQL, we couldn't do that because that API is part of ArcSQL and it would be dropped, so we can't actually depend on it there, but we can depend on it everywhere else. So this will drop the table. If it doesn't exist, it doesn't raise an error. It just says it's dropped, so that's a nice thing about that. Then we check we create an anonymous PL SQL block, and we check to see if the table exists. If it doesn't exist, we're going to run this SQL. This is basically just like execute immediate. You can go look at that procedure, and we create the table. So we've got an ID column. The nice thing about this is we have a procedure that runs at the end of install. It's also part of ArcSQL that kind of corrects all our IDs if they've gotten out of sync, because we're syncing data manually between environments. So as long as we create an auto ID column, it can be called whatever you want. That procedure will run and reset the sequences associated with these IDs. So that's kind of automation we want to just build in so you don't have to think about it. User ID is required, not null, and I also have username. These are a bit redundant, but what I'm finding in the API is a lot of times you have access to the username because that's the within Apex, that's VApp user, but that's not our primary key column for the authorization ID. So sometimes the API you may want to call username, but in the procedure that we call, we'll go ahead and figure out the user ID and make sure that gets populated, because when we delete a user from SAS auth, we want cascade delete to delete it everywhere else in the system as easily as possible. There are some places where it's kind of optional and there's going to have to be kind of a manual cleanup, but I haven't figured that one out. There's some flash message. There are tables that you would like the flash message table where you would normally associate a message with a user, but it's entirely possible to just associate it with the session. And so in that case, you can't really have that foreign key constraint with the cascade delete. So presents a small problem that we'll deal with through a cleanup job on the back end or something like that. But that's why we have this. It's kind of redundant. Username's not required, but the API will probably take username and then figure out user ID from that. Then we have our token. I think this will be just sysGUI ID. That should be unique and random. I haven't validated that it entirely is, but again, we're not building the most secure application at the moment. We could always create our own tokens, we could assign them, we could do all kinds of things to verify that those tokens are valid. They shouldn't be easy to guess, and there should be kind of some kind of throttling. That's built into Oracle Apex. There's areas that I'm using it where you're doing request throttling, like on the login. If you go look at the login code, you'll see that it's actually counting those requests, and it kind of does a sleep back off if you get too many requests too frequently or something like that. It's hard to keep all this stuff in the head all the time, but there's something there for that. Of course, we want expires at. Null would be never expires, but pass in a time for that. Created at, we want to know when it was created. Auto login, so a lot of times when you've used a token like I'm doing now for filling your weight, we're going to want to automatically log the user in at the same time, just out of convenience. We know it's the user. We know that it would be silly to log their weight and then make them log in. So we could build that into the code, or this seems like a pretty easy place to put it for now anyway, and we'll just have that do an auto login. if that's set to Y. And then max use count, so tokens, maybe they can be used a limited number of times. Usually it's going to be a one-use token, but maybe you would allow more uses than that for some reason. So throwing that in there, don't have a use case for it yet. But in general, if you hit a page with a valid token, you're going to be able to do whatever that page allows you to do. We're not going to have like, what can this token do at this point other than auto login. If down the road we come up with something that needs higher security, we'll figure out a way to wrap this so that the token is, like I said, either signed or something, and something of that nature that tells us what we can do with the token, and that way we maybe can do that, or we can store it in this table or something like that. Now you'll notice we check for constraints outside of the create table block individually. You'll probably find lots of places where this is just thrown up there. So it's like if the table doesn't exist, build the table in the constraints. But there's the rare chance that a constraint gets deleted, and then it would not get rebuilt unless the table got deleted. And so we want to put this block outside, trying to keep everything idempotent. So you can run this script over and over, and it always does the right thing. It always builds the things that need to be built. So even if the table exists, if this constraint doesn't exist, it tries to add it. Same thing with the foreign key constraint. Haven't added any other indexes at the moment, and I did test this block in SQL Developer, and it created my table and all that, but you can run it over and over. So if you don't know what idempotent means, or idempotency, go look up some videos right now on it, and just make sure that you understand that concept. The concept that you can just run your install script multiple times against any version, ideally, of your product, and you always come out with the current version, and everything that was broken gets fixed, all that kind of stuff. So important concept, and makes life a lot easier, and that's how I manage my tables and stuff like this. So far, using this particular I know there's a Liquibase or something like that a lot of guys and gals with Oracle use. I looked at it many years ago. Maybe it's a lot easier now, but I like this. I can store this in my Git repository. I can see the version history. I have the concept of like patching. I can create a patch procedure. I've got some versioning in here. So it's just plain text, and it tells me the state of my schema and my application, and I like doing it this way. It's all stored with the code. So for K2 development, if you're going to do it, I recommend you take a good look at this. And if there's some feature that doesn't exist, just consider adding it. It isn't that hard to create one of these functions and add it. It would go into ArcSQL. Let me show you. We'll go into ArcSQL. We would go into schema support. And that's where all those functions, drop view, drop function, drop procedure, drop type, all that junk is. And there's the most recent addition, fixed identity sequences. So if you see something wrong with the logic here, you should be able to check out the repo, make your changes, and submit a pull request for me to make changes, try to stick to the coding style and all that. If you have an issue, raise it if you think it's important, and there's good reasons for it. If it's just a preference, I'm probably not going to pay much attention to preferences. Okay. Anyway, that's it. We'll catch you later. Thanks.